Okay, I want to talk a little bit in this video about demand estimation, which is in Chapter 5 of your textbook. One of the things that we worked on in Chapter 3 and 4 is how to calculate the demand uh, using only price as the variable against quantity. So, for example, in the pizza example that's in your text, the company wants to know what are all the variables that affect the demand for my piece of slices. And they have listed the college there is not a variable, but just a listing. The quantity of piece of slices sold, the price that was charged for the pizza, and then they have a couple other variables, which we'll talk about in a minute. So the simplest demand estimation would be to take just the quantity and the price and go to a scatter diagram and run those two against each other. So let's do that. We'll select the data, add, and we'll put the title in. That's going to be quantity, and the x values will be these quantities. Then we have to put in the y value, which when we're drawing a graph in economics, we use price on the vertical axis. So that's that quantity there. So we lay that out, and we end up with our demand curve. Now, our demand curve doesn't look like a line because we're actually getting error measurements, and that's what happens in reality. You go out in the real world, take sampling, you don't get a perfectly straight line, but you can estimate a line that would go through the data. So we could go to one of these positions and then say add a trend line and ask it to display the equation and also to give us the R squared coefficient of determination. And if we do that, we find that the coefficient of determination is 0.5169. And what that means, as you remember in statistics and in your current text, that 51.69% of the variation in the quantity of pizza slices sold is explained by the price you are charging for the pizza. All right? So you might look at that as a pizza shop owner and say, oh, I'm not getting enough explanation. I'd like to know if there's more involved. So let's eliminate this curve and go to the one with more variables. Okay, so now they go out and they determine a couple more variables. And one would be, well, what about the price of soft drinks that we charge? If our soft drinks are too expensive, it makes sense that people might go somewhere else to get their pizza. So we want to make sure that our soft drinks are priced correctly for what we're really trying to do, which is to sell pizza. And the other thing they used is, well, maybe the income of the students would show us a relationship between how much pizza we sell. So let's use tuition as a measurement. So the different colleges they studied their pizza shops near, they have tuition as a measure of income, basically, assuming that a higher income person might buy more pizza. They wouldn't care what the price is. So anyway, so what we use for a tool there is we go to data analysis, which you should have loaded on your Excel already from when you took statistics. But if you don't, go to the help screen and type in data analysis tool, and you'll get some pretty simple directions on how to get the data analysis tool to show up on your toolbar. Okay, it does not come as a default on Excel, but it is inside the package. You just got to bring it out. Okay, so now we go down to in the data analysis tool, we pick regression, and we have to tell it what we want to regress. Okay, the Y range is going to be the quantity. That's what we're really interested in knowing, is what's going to affect the quantity of pizza slices that we sell. And I notice how I also click the quantity data descriptor at the top of the column, so I have to say that I have a label on my data. Now I need to put in what's the X range. And that's going to be these three variables all at one time, including their labels. these two variables added in. Whoops, I'm sorry about that. It is all three variables. I'll try that again. Here we go. I'm going to get all three of these variables that we think affect the quantity of the pizza prices we sell and include them all in. And I get a chart. Now I'd have to say where I want to print the chart, so I'm going to say, put it on this sheet right here. I pick output range, and I pick a place where I'd like the chart to show up, let's say there. And then I say that my confidence level, I'd like 95%. I'm ready to go. And there is my ANOVA diagram. In other words, it's telling me what the variation is. Now, this is a multivariate regression. And up here, notice that the R squared is now 0.71. So adding in those two more variables, the tuition and the price of soft drinks, has now explained more of the variation between the quantity I sell and those variables. So this would be preferred over the first one that I showed you, which only explained 51%. So we've improved our ability to estimate the quantity demanded by adding in variables. Okay, and we have to go to the F table in the text and put in for the degrees of freedom across the numerator 3 and then down to column 26. That F table is in the back of your book in an appendix. You get a number something under 4, I believe. I can't remember the exact number. You need to be greater than that if this equation is significant. And when the F square, when the F statistic is greater than the test statistic, which it would be in this case, then the equation that you've just been given is significant statistically. It is not an accident. Okay. Now here are the t-values for the different variables. Anything greater than 2, absolute value of 2, is a significant variable. And the first one is the price of the pizza itself, and it is a -6, which makes sense. It's going to be inversely related. The lower the price, the more you sell. The tuition is less than 2, absolute value 2 for the t-value, which means that this is really not that significant. But we leave it in the equation because our F squared, or our F value, says that this equation is going to be significant, even though this particular value, we really don't have a lot of statistical strength for it. And then here is the price of soft drinks, and it is also a value greater than 2, and therefore the correlation there is significant. So you do need to keep the price of your soft drinks down if you want to sell more pizza. Okay, so the equation that we now have for demand just get a little bit more complicated. It's going to be the quantity demanded of pizza slices is equal to 25.31 minus 0.08 times the price of the slices in cents, the plus 0.13 times the tuition charged at the college nearby, and minus 0.07 times the price of the soft drinks that we sell. So we have a much improved ability to estimate. We're now gone from 51 to 71. If we wanted to continue to put our thinking caps on, we might come up with another variable that we could measure. I know in the book they add another variable. I can't remember what that was, but there could be other variables, whether it's an urban setting and things like that. But you can keep working with this. You can end up with 7 or 8 variables and get closer and closer to explaining what your demand is going to be as those variables change. I hope this helps you with Chapter 5.